Hi guys, it's Mr. Krieger. We're going to continue that lesson, Inference without a calculator. This is going to be the part 2 of 2. We're on to question number 3. The next 3 questions are all confidence intervals. And again, what we want to take a look at is we want to take a look at how to do them just with the reference sheet. I mean, obviously you could use the calculator, but the reference sheet we're going to use instead of using the tests on in the stat button, okay? So let's take a look at this problem. You take a random sample of 48 Hewlett residents and ask them how much money they spend on takeout food per month. You find that the data is normally distributed with a sample mean of $347 and a sample standard deviation of $123. Create a 95% confidence interval to capture the true mean value of takeout among Hewlett residents. There's a follow-up question here. I'll take a look at it afterward, okay? I'm actually going to right here because I might need a little more room, especially because I have to use a thick pen. All right, so first thing, conditions check. Let's think about that. Well, it's always the usual. Is it a random sample? It says so. You would write that down. Normality. In this particular case, you would say, well, there's a 48 residents, so that meets the central limit theorem, the CLT. And for independence, you would need to say that there has to be at least 480 Hewlett residents, and that's very reasonable to assume. Okay? Now, how do we do confidence intervals here? Well, one thing we got to do is let's take a look at what it says about confidence intervals, and that's right over here. Confidence interval is the statistic plus or minus the critical value times the standard error of the statistic. So let's take a look more carefully what that means. So let me fix the camera. So the statistic in this particular case, this is confidence interval, CI, the statistic is going to be X bar. That's what we have as a statistic. It's going to be a plus or minus the critical value. So the critical value is either T or Z, depending on which type you're going to be using, times the standard error. In our particular case, in this example here, it looks like we have the sample standard deviation. So since we're going to be using the sample standard deviation, we're going to use T, plus we're going to use S, the sample standard deviation, over the square root of n. This is how we build our confidence interval. Okay, it's pretty easy. Here's a few things that we got to do. First of all, this part's easy, X bar. That's the mean, the sample mean that you have, $347. So it's 347 plus or minus. Now this part here, this is the margin of error. This whole thing. Well, I said it's going to be T because it's the sample standard deviation. And in order to find the T value that we're going to put here, what we're going to need to do is we're going to have to look at the type of confidence level we have, which is 95%. So let's think about this. If you're going to need a 95% confidence interval, then that means that you need 2.5% of the area here and 2.5% of the area here, which means to get from negative infinity all the way up to here, that's going to be 97.5% of the area. So we need a T value that's associated with 97.5% of the area. How are we going to do that? Well, here we're going to use our calculator because you don't have to use your tables. That's not necessary. What you're going to do to find that T value is you're going to go to second distributions. You're going to do inverse T, INVT here. And what you're going to do is you're going to put in the area, which is 0.975. And your degrees of freedom, remember how to find degrees of freedom. That's going to be number of people, 48 minus 1, 47. We're going to paste that, and we get that the T value is 2.0117. I'll just use 2.01. Actually, yeah, 2.01. So that's 2.01. And now for this part right here, they gave us the sample standard deviation, which was 123. We have to divide that by the square root of 48. That's not the degrees of freedom, that's the actual sample size. And that gives us a margin of error. Let's see if I have it here. That gives us a margin of error of 35.71 4. In other words, in order to create our confidence interval, we're going to do the x bar plus or minus that margin of error, the t times that standard error. So that gives us the following values. The low value, when we subtract, is going to give us 311.29, and the high value is going to be 382.7. And what we're going to say now is the following. We need to actually create a conclusion. Remember, you always say this. We are 95% confident. That's how you start off writing about a confidence interval. That the true, again, this was a sample mean, but we need an expression or a value for the true mean, or at least a range for the true mean, that the true mean, and now we need some context here, the true mean of money spent on takeout in Hewlett is between $311.29 and actually I have over here $382.71. So it's between these two values, okay? So the true average amount that Hewlett residents spent are in this range per month, okay? And that's what you would put in context. Now, what would happen if you increase the confidence level to 99%? Remember, if I want to be more confident, I'm going to have to make a wider interval. So the interval is going to be wider. Now, we could actually compute this, but I'm not going to. Maybe it goes from 300 to, let's say, 392. To get, there's going to be a greater likelihood that that the true mean is within a larger interval rather than in a smaller interval. So that's what you would write down for what would happen if we increase the confidence level. You'd have to make the interval wider. Okay. Let's take a look at the next problem. I'm gonna move this up a little bit, and hope you can see that. Yeah, you should be able to. Okay, let's take a look at this. The National Survey of Student Engagement asked a random sample of 732 students if their peers at least sometimes copy information from the internet in their reports without citing the source. 576 students from the group said their peers did. Basically they're cheating or they're plagiarizing. Okay, make a 95% confidence interval to find the true proportion of students who make this claim. And again, as always, you'll have to check your conditions. Now, the conditions for here, this is a proportion. This is a proportion thing. So the conditions are going to be, simple random sample, SRS, you have to say whether it is or not. You're going to have to check independence. Now, you have 737 students. It's a national survey. There has to be at least 7,320 students in the population. I think that's very reasonable, but you must say that. But for normality, you have to check these conditions. N times p hat has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or equal to 10, okay? How do we do this? Well, n is 732. P hat is the proportion, 576 over 732. And this product is obviously 576. That's greater than or equal to 10. And we'll have to check this one too, 732. And that, to get the 1 minus p hat, you do 1 minus that. It's going to get you 156 over 732. And that's going to be 156, which is also greater than or equal to 10. So we're good with the normality condition. So we can go ahead and do a confidence interval here. Now the confidence interval, like before, still has to do with your statistic plus or minus that critical value, I'll just call it CV, times the standard error of the statistic. Now in this particular case, the statistic is the proportion, that's p hat, okay? Let me just move this down here so I have an easier time writing. Okay, so p hat and plus or minus, because it's proportional stuff, we're going to be doing a z value. And then the standard error is going to be, well, let's see. Let's go take a look at our reference sheet. Now, the standard error for the population, the proportion is going to be the square root of p hat times 1 minus p hat over n. Okay? So that's what we're going to need here. It's going to be square root of p hat times 1 minus p hat over n. We'll do the radical. Okay? So what's p hat? That's 576 over 732. That is the proportion, our proportion from the sample. That may or may not represent the true population proportion. Probably not. That's why we're making a confidence interval, which will hopefully capture the true value of the proportion. Now, we need the z value. Well, to find the z value, we need to find the confidence level. We're doing a 95% confidence level, so the z value associated with a 95% confidence interval is 1.96. But if you're not sure how to get that, please remember, I'll do this over here. 95%, again, you need 97.5% of the area to be from negative infinity to here. So we're going to go to, just like we did before, but instead of doing inverse t, we're going to go to inverse normal, and we'll put in 0.975. Always use, this is for the standardized distribution, 0, 1. Let's see if that gives us 1.96. Well, we knew that already, but I just wanted to show you how to get it. 1.96, and now we just plug these values in. By the way, this proportion turns out to be 0.787. So when we actually do this computation here, it's going to be the square root of 0.787 times the difference of 1 minus that, which is about 2.213, over 732. Which gives us, if you multiply this out, a margin of error of 0.02966. So if we add this and subtract it, we get a confidence interval of 0.7573 and 0.8166. And now we have to summarize, make a conclusion, and we, again, as you know, we always say we are, in this case it's 95% confident that the true proportion of students who claim they know someone who plagiarizes, who claim they know someone who plagiarizes is in the interval 0.7573 and 0.8166. Basically, it's saying between 76% and about 82% know somebody who plagiarizes. Okay, so that's how we do this problem. Last problem, it's an AP statistics problem from 2009. Let's take a look at that. Just get ready. You could start reading it. All right. One of two fire stations in a certain town responds to calls in the northern half of town, and the other fire station responds to calls in the southern half of the town. One of the town council members believes that the two fire stations have different mean response times. Response time is measured by the difference between the time an emergency call comes into the fire station and the time the first fire truck arrives at the scene of the fire. Data were collected to investigate whether the council member's belief is correct. A random sample of 50 calls selected from the northern fire station has a mean response time of 4.3 minutes with a standard deviation of 3.7 minutes, and from the 50 calls from the southern fire station has a mean response time of 5.3 minutes and a standard deviation of 3.2 minutes. Part A is construct and interpret a 95% confidence interval for the difference in mean response times between the two fire stations. So we need to make a confidence interval for the difference between two fire stations. So basically, we want to find this, x1 minus x2, and we're using it to represent, we're using this to represent mu1 minus mu2, that mean difference. We're hoping that there's no difference in these two fire stations, but there could be. You know, when you look at it, it looks like this station, the one that takes 4.3 minutes, responds faster than obviously the one that has a 5.3 minute response time, but that could just be due to natural variation, so that's why we make a confidence interval. Okay, so here's how we do this. We do, and let's see over here. No, we don't, actually we can just do this. This is what we're trying to find the interval for, and then we're going to have to add on, and this is, we have sample standard deviation, so we're going to use the t-value, and then we're going to do square root of s1 squared over n plus s2 squared over n, okay? And now we're going to have to plug in what we know. So what I'm going to do is I'm actually going to reverse this. In order to get a positive difference, I'm going to use the 5.3 as my x1. So I'm going to do 5.3 minus 4.3 plus or minus. Now our t-value, again, we're going to have to use the t distribution, and we're going to have to do the inverse t in order to find that value. What we're going to do is this. We have two n values of 50 each, right? So we can actually use that value of 50 as our n, and do n minus 1 to get our degrees of freedom of 49. So we're going to go back to inverse t, and the area is going to be, again, for a 95% confidence interval, it's 0.975. Degrees of freedom is 49, and we get that's just about 2. So I'm going to put a 2 here. And then how do we get these? Well, S1, I'll try to fit it in here. S1 is 3.2, but don't forget to square that, over 50. Oh, and again, you might be wondering where we get this from. This stuff I got, let's find it over here for you. Hold on one second. Here we go, right over here. This is the difference between the standard deviations for two population means. So that's where I'm getting it from. Okay, this is 3.7 squared over 50. Okay, I'm going to put that into the calculator. By the way, this is 1 plus or minus 2 times. So we're going to do square root of 3.2 squared divided by 50. I'm going to close parentheses here. Plus 3.7 squared divided by 50. And that gets us 0.6918. 0.6918. This is going to be our margin of error, so we're going to multiply that by 2. 1.38. So now it's 1 plus or minus 1.38. Now, if we subtract those, we get negative 0.38. And if we add those, we get 2.38, which means the difference in mean response times is between negative 3.8 minutes and positive 2.38 minutes. So that means it's possible that that one fire station takes 2.3 minutes, almost 2.4 minutes longer to respond, but it's also possible that they respond in less time. And now we can get to part B of this problem. Does the confidence interval in part A support the council members' belief that the two fire stations have different mean response time, and explain? I want you to notice that 0 is in this interval. If we were to do a hypothesis test, we wouldn't get any significant results. It's possible that there's no difference, even though this looks like a difference, because of the natural variation of the samples. There really could be no difference. So you would say, since 0 is in the interval, there is a possibility that there truly is no difference in these response times since 0 is in there, and that's how you would do this problem. Oh, by the way, I didn't really finish part A. You have to write a conclusion like we've done on the last few problems. You would say something like, we are 95% confident that the true difference between the response times of these two fire stations is between negative 0.38 minutes and 2.38 minutes. So don't forget that that needs to be done and all the conditions needed to be checked. But again, I just went ahead and showed you how to create the confidence interval because I thought that was a little bit tricky. Okay,